there, thanks for clicking on your next math video lesson. This is lesson 5-2 if you care to follow along in your textbook. Definitely going to want to have a calculator ready and most definitely going to want to take notes. In math class, as you know, we've been working our way through different kinds of equations. We did one-steppers and then we did two-steppers and now we are into even more difficult equations. These are called equations with variables on both sides. They are otherwise known as multi-step equations, and as you can see on this screen, this is day one. And in fact, we're going to spend quite a few days with these multi-step equations. So, I have some little steps for you. Now, this is my suggestion for how you should handle a multi-step equation. And this is what I have found that just simply works the best. It's the most reliable approach to handling or solving these equations. All right, so if I were you, I'd write this down. To solve equations with variables on both sides, step one would be to get the constant terms together first. Now, in case you don't remember what the constant terms are going to be just your plain old regular numbers. So if you're looking at an equation and you notice that it has like a 5 on the left side and a -2 on the right side, you're going to want to get those numbers together first. Somebody's going to have to move to the other side of the equation across the equal sign. So we're going to focus on our plain old numbers first. Then, once we have those squared away, step 2 would be to get the variable terms together. So again, as you're looking at these equations, you're going to notice that maybe there's a 5a on the left side and a -4a on the right side. You're going to have variables on both sides, and that's not okay. So we're going to have to be moving an entire variable term from one side of the equation across the equal sign to the other side of the equation. So we'll be getting our variable terms together. And then the very last step will be, it'll seem simple to you now because you've been doing this for so long, will be to isolate the variable, right? Get that grumpy variable alone. So here we go. Now, these are starting off pretty easy. I'm looking at the equation here on the left, and here's what it says. It says, as you've been trained, 1x plus 6 equals 3x. Okay, now I said step 1 was to get your constants together. So if I'm looking at this equation, I see that there is one constant here, and it is plus 6. Now, there's nobody else like him. There are no more constants in this equation, so there's really nothing I can do with that plus 6 yet. He doesn't need to move to the other side of the equation to join up with the other constants because there aren't any other constants. So for now, he can just stay plus 6. So step 2 is to get your variable terms together. Now I'm looking at this equation and I see I've got a 1x, that's a variable term. That's on the left side. And on the right side, I've got a positive 3x. That's a problem. When you have variable terms that are like terms, but one's on the right side of the equal sign and one's on the left side of the equal sign, somebody's got to move. You've got to get your like terms together on the same side of the equal sign. So I either have to take that whole 1x term and move it over to the other side, or I have to take the 3x term and move it over to the other side. But here's something we haven't talked about yet. You are never allowed to leave one side of an equation empty or with a 0. Well, I shouldn't say never. For now, we're not going to allow you to have a 0 on one side of the equal sign. So if I'm looking at the 1x and the 3x has to stay put. He cannot go anywhere. He's got to hold his spot there on the right. So now I'm looking at this plus 1x. He's moving. He's got to get over to the other side to join up with this other like term. So I am not dividing by 1. I am not breaking the 1 and the x apart. No, we're moving the whole thing. And right now, this whole thing is plus 1x. we move it, again, like always, by doing the opposite. The opposite of add 1 is subtract 1x. You're moving the whole thing over, and you have to do the opposite of that. So if I subtract 1x on the left, I have to subtract 1x on the right. On the left, the plus 1x minus 1x cancel out. And I rewrite. Now on the left side of my equal sign, I have a positive 6. And on the right side, 3x minus 1x is 2x. Now, I bet you know what to do to isolate the variable, to get that variable alone. Now you're going to break the 2 off of the x. And right now it's 2 times x, and the opposite is divide by 2. So that the 2 is gone from the x now. There he is. He's alone, and he's positive, and he's happy. And 6 divided by 2 is 3. Final answer, the value of x is 3. I promise you'll catch on. This does get better. Okay, let's look at the next one here on the right. It says 4y equals 2y minus 10. Look. Start with the constants. I see one constant, it's minus 10, and there are no more like him, so he just gets to hang out for a minute and be patient. Step 2 is look at your variable terms. I've got 4y on the left and 2y on the right, and that's a problem. I got to get my y terms together on the same side of the equal sign. The 4y cannot move over. He has to stay put, because if we move him away, then that left side of the equation is empty, and for now we're not allowing that. So that means you have to move that 2y over to the other side. We're not going to divide by 2. We're not breaking the 2 off of the y. We're moving the whole thing, and right now it's plus. So subtract, right? Always do the opposite and do it to both sides. The whole thing is now gone. We've moved it to the left. And 4y minus 2y, because 4 minus 2 is 2. So 2y. And on the right side, you don't have a 10. It's a negative 10. Last step is to isolate the variable, right? Break that 2 off by dividing by 2. So those 2's go away, and y equals negative 10 divided by 2 is negative 5. Be very, very mindful of those negatives and don't make careless errors. Unfortunately, they're so easy to make. Careless errors. Okay, these get a little bit longer. Let's take a look. This one says 7m minus 4 equals 12 plus 3m. Start with those constants. I see a minus 4 on the left and a plus 12 on the right. Somebody's got to move. Somebody's got to go to the other side and join up with the other guy. I'm going to move the minus 4. I'm going to move the 4 to the other side. Now, you don't have to. You could move the 12 to the left side if you'd like to, but I'm going to move that minus 4 and get rid of it. So, you do the opposite. Instead of minus 4, we add 4. On the left, I just have my 7m, and on the right, 12 plus 4 is 16, and there's the plus 3m still waiting for some attention. Now I look at my variable terms. I see the 7m on the left. He cannot move. And I see the 3m on the right. He's moving. It's moving day. He needs to jump on over to the other side so that he can combine with the other m. And right now it's plus 3m, so we're going to subtract 3m. There. Now it's gone. And on the left, 7m minus 3m would give you 4m equals 16. Now isolate the variable, break that 4 off using division. 4's are gone. M equals 16 divided by 4 is 4. Multi-step equations. There's a lot going on in these things, but you just have to take it step by step. Don't get ahead of yourself and don't get overwhelmed just by the look of an equation. Here we go. 10t minus 3 equals 1t plus 15. All right? Constants. Look at your plain old numbers. I see, I'm going to do this because I like this. I see a minus 3 and I see a plus 15 and somebody's got to go. I'm going to move the 3 over to the other side. So, instead of minus 3, plus 3 on both sides. So, now it's gone from the left, and all I have on the left is 10t equals 1t, that hasn't changed, plus 15 plus 3 is plus 18. Okay? Step 2, variable terms. I see 10t on the left, 1t on the right. The 10t has to stay where he's at. He's like stuck there. So we need to move that 1t over to the other side. Right now it's plus 1t, so you're going to subtract 1t. Now it's gone from the right-hand side, and that's good. On the left, 10t minus 1t leaves 9t, and on the right, I've got positive 18. Last step, isolate the variable. So instead of 9 times t, you do the opposite and you divide by 9. Bye-bye to those 9s. T is alone, positive, and it's happy. 18 divided by 9, 2. The value of t is 2. The thing is, these equations are all going to be just a little bit different from each other. So you have to learn the strategy. You have to learn the steps. This is the last example for this lesson. 28 minus 1x equals 3x minus 84. The constants would be positive 28 and negative 84. Somebody's moving. I don't care who you move. You can move either one. You can either take the 28 over to meet up with the 84, or you can take the 84 over to meet up with the 28. Doesn't matter to me. I'm going to move the 84. So right now it's minus 84. Let's do the opposite and add 84. And if I add it to the right, I have to add it to the left. And bye-bye to the 84s. 28 plus 84 is 112. I still have the minus 1. Oops, that's supposed to be an x. Hold on. There we go. I still have the minus 1x there. And on the right, I've got a 3x. Okay? Step 2 is look at your variable terms. I see an x on the left and an x on the right. Somebody's got to move, and the guy on the right has to stay put, so the guy on the left has to cross over. So I'm going to move the minus 1x by adding 1x, always doing the opposite. See you later. I have 112 on the left. There's my equal sign. 3x plus 1x, 4x. Isolate your variable. Get that grumpy variable alone, so we're going to divide by that 4. Bye-bye to the 4s. X is alone. He says, thanks for all your hard work. You did a nice job. And 112 divided by 4 is 28. Final answer. These are complicated equations. They are multi-step, which is why we're going to spend a few days on this idea. This is what we'll be working on in class, and of course you're going to be asked to show your work. And kind of a new twist is that a couple of our answers today are going to have decimals and fractions. So we'll definitely be working with our calculators. Thanks for checking in, and thanks for giving it a shot and trying to think about some new concepts, right? You're learning new things. I'll see you in class.